Hello, I am Meherchand and welcome in this tutorial series on computing mathematics with Python. The agenda of the present lecture is to solve a system of equations, linear and non-linear algebraic equations. We will solve these equations with the help of Sympy, and as you know, in the previous lecture we introduced Sympy for scientific computing, which is highly used for symbolic mathematics and various type of scientific computations. So let's start the today agenda. You can see the symbolic equations in Sympy are not represented by symbolic equations are not represented by the equal sign or double equal sign, but we use this function which is inbuilt function in Sympy. Suppose we have the equation x is equal to y. So we will use this function to represent this equation. EQ is a function, then this x is left hand side of the equation and y is right hand side of the equation, and both are separated with the help of comma. So when you will enter, this will return the equation which is x equal to y. See, first you need to open the live mode of Sympy, and the URL for the same is live.sympy.org. You can see carefully, and when you will enter, we have the Sympy on live mode. Also, you can make its full size from this place. Now we operate all these operations here. EQ is the equation, and x comma y, and enter. So this will return x is equal to y. Suppose that we have one more equation, EQ, we have x plus y minus 2 is equal to 0. So the left hand side of the equation is x plus y minus 2 and separated by comma. Right hand side is 0. When we will enter, you can see the equation we have is x plus y minus 2 is equal to 0. And sometimes the equation, however, there is an easier way to represent the equation. In Sympy, any expression is not equal to is an equation automatically assumed to be equal to 0, and because if we have a is equal to b, this will be possible only if we have a minus b is equal to 0, and this is the main reason that instead of x is equal to y, we can write x minus y is equal to 0. We want to solve the equation. First we use the equation function to write the equation, and then we will use the solve set function. For example, we have the equation x square is equal to 1, and we want to solve this equation. Then first we convert in syntax EQ x, this is the product sign, and then 1. So the left hand side of the equation is x square and 1 is the right hand side. Then we have one more operator which is a solve set. This solve set will be used to solve the equation, and this is the complete syntax which will be used to solve the equation. And see in the Sympy, we are using solo set to solve the equation. And EQ question is, we have x square is equal to 1. Okay, x square is equal to 1, and we want to solve this equation for x. We want to solve this equation for x, then n. So this solo set function will return the all possible solution for the equation. Okay. Similarly, this is the another way to use or to solve the same equation, which is here is the expression, and the above equation can be written is x square minus 1 is equal to 0. So this is the left hand side and this is the right hand side. And this is the another way to solve the same equation, but here we are not using EQ. We can directly use the solo set function to solve the equation without using EQ, and both will return the set of the solutions. So here we are using the solution set, which is x square minus 1 is equal to 0, and when you will enter, this will return the same set of solutions. Either you can use the equation without using the equation function. Just we need to write the equation, and then we will use the solo set function to solve the same for x variable, and when you will enter, it will return the same set of solutions. The most important thing is, please note the syntax for the above equation. We did not use here EQ function. Okay, directly we can use solo set function to solve the equations. Now, how we can solve the algebraic equations? So see the syntax first. If we have the equations and we want to solve the algebraic equations, we need to use solo set function, and this is the syntax which will be used for the general case. Solo set, then we have the equation. After that, we need to declare the variable. Okay, and if domain is required, we can assign the domain in this way. Domain is equal to s dot, if the domain is complexes or it is reals, we can assign, if it is complexes, then s dot complexes. If it is real, then we will assign here reals. Okay, so these are the ways to use the solo set function for the algebraic equations. Also, there is one more function, solo, which can also be used for the same to solve the algebraic equations, and the syntax for the same is solo equations then variables, but the solo set is recommended instead of solo function. There is some reason, and when we will employ this, then we will see the difference of the solutions. So here we are using the solo set to solve the equation. You can see we have x square minus x is equal to 0, and we want to solve this equation for x variable and using the solo set function, and this is the syntax for the same. Come here, we are using solo set function, and the equation is x square, then we have minus x, and we want to solve this equation for x. Then when you will enter, we have the set of solution for the same equation. Very quite easy to use, The another way is if we have the equation x minus x is equal to 0, and we want to solve this equation for reals. Okay, so the domain is reals which will be inserted in this way. Domain is equal to s dot reals. C solve set, and we have the equation x minus x. We want to solve for x variable, and domain is equal to s dot reals, and when you will enter, it will return the solve set which is real. There is one more example for the same. We have the equation which is sin x minus 1 is equal to 0, and we want to find out the solution for the same. This is the syntax for the same. This is the equation, then x variable, then domain. We are using a solve set, and we want to solve sin x minus 1. Sin x minus 1, okay, is equal to 0, and domain is reals, then enter. So this is the returning value of the set of solutions for the equation which is sin x minus 1 is equal to 0, and which is 2n pi plus pi by 2, where n is integer. So here sometimes if there are no solutions, empty set will return, and if this solve set function is not able to find out the solution, then we have condition set, it will return. For example, if we have the equation like exp is equal to 0, so it has no solution, and if we have the equation which is cosine x minus x is equal to 0, this is not able to find out the solution. Let's try in Sympy. We have solve set, and we want to solve the exponential function for x, and then enter. See, it is empty set. It is returning empty set because there is no solution for the equation, which is exponential of x is equal to 0. If we have in the place of exponential, we have cosine x. Okay, we are using cosine x, then we have minus x, and we want to solve this equation for. Okay, so when you will enter, it is returning the equation without solving it, x such that x belongs to C. We have minus x plus cosine x is equal to 0. So the solve set function is not able to find out the solution of the equation. So it is returning the solution or value without solving it. If we want to solve the system of linear equations, then we have the module of solve set, and for the linear system of equations, the module is linsolve, which is the one of the module of the solve set. Okay, so whenever you have the system of equations, then we will use linsolve. For example, we have these two equations. One is x plus y plus z is equal to 1, and second is x plus y plus 2z is equal to 3. So this system of equations can be easily used. So first convert this equation x plus y plus z minus 1 is equal to 0, and second equation can be written as x plus y plus 2z minus 3 is equal to 0. So this is the system of equations. This is the first equation and this is the second equation, and we want to solve this system of equations for x, y and z, and we are using here Lin-Solov function. See how we can employ this Lin-Solov function to solve the equations. So here we have Lin-Solov function. We want to solve the system of equations by using we have the first equation, which is x, then we have plus y plus z, and we have minus 1. Then we have second equation, which is x plus y plus we have 2z, this is 2z, and minus 3 is equal to 0, and we want to solve this system of equations for x comma y comma z, and when you will enter it will return the set of solutions. C. Yes, this is the set of solutions. There are three values: minus y, minus 1 for x, y for y, and 2 for z. So this is the corresponding solution for x, y, z. Suppose if we insert one more equation in the above. Here I am entering one more equation. Suppose that it is x minus y minus 3z and plus 2. Okay, and when we will enter, this will also return the solution. So whatever have the equations, you can easily use a Lin-Solov function to solve the system of equations. It's very quite simple to use, and the corresponding values of the set of solution we have is 3 upon 2, minus 5 upon 2, and 2. Here we have one more example. We can use if we have augmented matrix form, we can use this form also, and this is also very quite simple. First we need to reduce this these two equations in the matrix form. You can see from this place to this place, this is the matrix form of the above equations. For the first equation, this is the coefficient of x, this is the coefficient of y, this is the coefficient of z, and this is the right hand side value. And for the second equation, coefficient of x, coefficient of y, coefficient of z, and the value of right hand side. Then we will solve the system of equations for x, y, z. See here, we are using the Lin-Solov function, Lin-Solov, and then with the help of a matrix, and here is this is the first equation. Just we need to choose coefficient 1 comma 1 comma 1, coefficient of x, coefficient of y, coefficient of z, then equal to 1, and this is for the second equation. This is for the second equation. Coefficient of x is 1, coefficient of y is 1, coefficient of z is 2, and is equal to 3. Then we want to solve this system of equation for x, y, z. We want to solve for x comma y comma z, then enter, then enter, and it will return the solution, which is minus y minus 1, y and 2 same as above. Either you can use this statement or you can use this statement. The both syntax will return the same solution. So these are the different ways to solve the system of equations. Here is one more way to solve the system of equations. If we can convert or we are given ax is equal to b in the matrix form, then first we denote the matrix of which is 1 1 1 1 1 1 2 3. This is the matrix, and then we will convert the matrix in the system. Okay, so see, here is the system. A is AB, so this is the A matrix and this is the B matrix. M double colon comma double colon colon comma colon minus 1 and M colon minus 1. Minus 1 means from the last row. See, we have 1 1 1 and 1. Here is 1 1 2 3. So when you will choose this one, this will take only this value, and when you will use this one, this will use only these values. Okay. So this is the way. This is the last column. So here is, we want to take first column, then we have second column, then we have the last column is this one. It will choose in the same way. Then we will use here line solve. This is the way to write the system of equations. And first is system, then xyz. See here. First we have the matrix. First we have the matrix, which is M equal to this one. M is equal to this value. Okay, this is the matrix. Then we need to write a system. System is equal to, we have A, then B is equal to M double colon minus 1. Then we have colon and minus 1. So this is the system. We have M is equal to matrix. This must be in this form. Here is also this one and this one and this one. Here is comma. Again it is returning some error. Okay, so this is the statement, and now we will use the line solve function. So using the line solve function, and here is a system, comma x, comma y and comma z. So system will be solved with the help by using in this way. So we are using the line solve function to solve the system. Okay, and when you will enter, we have the same solution as above. So in this way we can use this linear solver system, and there are various ways to use, and I hope this will be very helpful for all of you. So now we will discuss about nonlinear system of equations, and to solve we will have the solve set module, and in the case of nonlinear we will use non-linear solve, which can be used to solve the nonlinear system of equations. So these are the syntax to use for the nonlinear system of equations, and in the very first example we have two equations. One is x square plus x is equal to 0 and x minus y is equal to 0. This is the syntax. Okay, so non-linear solve, then we have the system of equations and we want to solve for xy. See, we have non-linear solve, and then we have the system of equations. First is x square plus 1, then we have y square. First we have x square plus x, then we have x minus y, and we want to solve the system of equations for x and y, x comma y. Then so this will return the set of solutions, all possible. You can see -1 and -1, this is the first pair, and second pair is 0 0. There are two different ways also when we have the solution in the complex form, and we can see the equations x square plus 1 is equal to 0 and y square plus 1 is equal to 0. In this case we have the solutions in the form of complex. And third case, you can see here is x square plus 2y square minus 2 and is equal to 0, and the next equation is xy minus 2 is equal to 0. Okay, so this expression also can be used to solve the system of equations. See in the Python, yes, here is a non-linear solve function, and we are taking the very first example, which is x square. System of equation is x square plus 1 comma y square plus 1, and we want to solve the system of equations for x and y. So this is the solution for these two system of equations, and the solutions are in the form of complex pair form. Similarly, we have one more example. See, non-linear solve function. Here is, okay, we can change here directly. Suppose here we have x minus 1 and this is x minus 1, y square minus 1, and this is x square minus 1. And in this case we have the real solutions. Yes, all the solutions are real. Now we have the last case. We can write the system of equations in this form. We have x square minus 2 y square minus 2 is equal to 0, and second equation we have is x minus y is equal to 2. We can write this system of equation in the system. Then we will declare the variables for which we want to solve, and then we will use non-linear solve function system will be at the very first place and this will be at the second place. Okay, see, first we have is a system, and the system will be represented in the form of we have two equations. One is x square minus 2y square, then we have minus 2. Second equation is we have xy minus 2. Okay, this is the system of equations, and we want to solve this system of equation for variables. Variables we have x and y. X and y are the variables. And now use non-linear solve function, and when you will enter, first we have then variables and then enter. Yes, so this is the another way to write the system of equations, and declare the variables, then use the non-linear solve function, and it will return the all possible set of expressions. In the present session, we will discuss how we can use Sympy and their inbuilt functions, which is a solve set, linear solve function, non-linear solve function, to solve various type of a system of equations, linear and non-linear equations. These functions are very helpful for scientific computing. Hope this will be very helpful and informative for all of you. Thank you to see this lecture till the end.